estimate the area under the curve of our function equals f of x equal x squared plus 3 along the interval from 0 to 2. So as you can see, I've got my picture graphed by first graphing the function on the interval along the x-axis from 0 to 2. Made a quick table of values. At x equals 0, 0 squared plus 2 is 2. At 1, 1 squared is 1 plus 2 is 3. At x equals 2, 2 squared plus 2 would be 6. I think that's a little bit too high. 1, 2, 3, 4, 5, 3. Yeah, plus 3. Thank you. Let me resketch this. Because this should start at I had x squared plus 2 in mind. But I changed it last thing. There we go. 0 squared plus 3 is 3. 1 squared is 1 plus 3 is 4. 2 squared is 4 plus 3 makes 7. There we go. Plotted my curve along the x-axis. All right, left endpoint. So it says use 4 subintervals of equal length. How long is the total interval from A to B? 2. 2 minus 0 should tell me the total length of my interval. Starting at 0, ending at 2, it's a length of 2. I want to subdivide that into 4 equal subintervals. So let's divide 2 minus 0 by 4. 2 minus 0 is 2, divided by 4 is 1/2. So we're going to subdivide this into 4 different subintervals, each with a width of 1/2. The first rectangle, since it's going to be a left endpoint, intersects the curve on the left-handed side at x equals 0. When you first start doing this, I highly recommend drawing a picture similar to what we're doing here. We're going to stack the next rectangle where the last one left off. Since I'm intersecting it on the left-handed endpoint of the interval, it starts at x equals 0.5, x equals 1/2, extends for a width of 1/2. One more rectangle. And our fourth rectangle runs from x equals 1.5 to 2. Here's a picture similar to what we would have seen on the GeoGebra applet that we looked at a minute ago. Area of a rectangle is base times height. All of these rectangles have something in common. What's the length of all of their given bases? 0.5 or 1/2. So if I want to find the accumulated area of these 4 different rectangles, let's take 1/2 times the summation of each of their respective heights. How do I find the height of the first rectangle? It'd be 3 because it's f of 0. The first rectangle runs from 0 to 1/2, and since it's a left endpoint, it intersects the curve at the left-handed endpoint. So I'm using left endpoints. From 0 to 1/2, I'm going to use f of 0 to find the height of this first rectangle. The second rectangle runs from 1/2 to 1 along the x-axis, since I'm using left-handed endpoints. Left endpoint of f of 1/2 should tell me the height of this rectangle, f of 1, f of 3/2 or 1.5. Got 4 rectangles, each with their base, respective base, the common base, times the summation of their heights. Questions on how we're setting this up so far? Okay. Let me pull up my calculator here and let's get some of these values identified. F of 0, what is 0 squared plus 3? Let's substitute 0 into our given function. It should be 3. All right, let's do the same thing with 1/2. All right, 3.25 or 13/4 as a improper fraction. One would be 4. 3/2. I've got 21/4. All right, let's total everything up here. I've got 3 plus 13/4 plus 4 and 21/4.
Ryder Rasmussen, please report to the secondary office. Ryder Rasmussen, report to the secondary office.
Gives me 15.5, or as a proper fraction, 31/2. The first rectangle's area is base times height, 1/2 times 3. The second rectangle's area is base times height, 1/2 times 13/4. Third rectangle and so on would have an area of 1/2 times 4. And for the last rectangle, 1/2 times 21/4. I'm just kind of condensing that a little bit because they all have the same base. Add them all up and we'll have the area approximation of the curve. 1/2 times 31/2. Which is 31/4. 7.75 or 31/4. Did I not get that added in right? Let me check that here. Should be the answer for the. Oh, these are switched around. That's right. Let's do that. Now that I've got that adjusted, would you guys finish up the right endpoints, midpoints, and trapezoids? We'll go over your work here if you had a chance to get the next few started on your own. As you're working, guys, we're going to take a few minutes and approximate the area by right endpoints, midpoints, and trapezoids. I've got approximations given by these decimals up on the board here as well. About 9.75 for right endpoints, 8.63 for midpoints, and 8.75 for the trapezoids. Yep, I had those switched around. We're good, dude. Halfway between 0 and 1/2. What's halfway between 1/2 and 1? Halfway between 1 and 1. Halfway between 1 and 1.5. 1 and 1/4, 5/4, or 1.25 is this one. Halfway between 1.5 and 2. 3/4 would be 7/8.
This one we would count, we would start where it hits the line on the right side. So would it be, the first would be f of 1/2?
Yep. Because if your first interval runs from 0 to 1/2, using the right endpoint of 1/2 would tell you the height of your first rectangle. Does that make sense?
Mm-hmm.
So if I do this here in red, right endpoint first look like this.
Mm-hmm.
Rather than all of the under approximations from our first estimation. These are all over approximations.
Mm-hmm.
So I'm going to stack the rectangle above the curve, since this is concave up.
Okay.
That's why they're called right endpoints. Use the right endpoint of your interval to give the height of the rectangle for our approximation. Grab the calculator and make sure that all of those values make sense.
Wait, so that graph up there, is that for the
Which one do you think? Right endpoints, midpoints, or trapezoids?
right?
Right endpoints, because each of the rectangles intersects the curve at the right-handed endpoint of the 4 different intervals. First rectangle runs from x equals 0 to x equals 1/2, so x equals 1/2, the right endpoint is where that curve intersects the rectangle. On the first one. Square equals 3. 1/2 squared. Oh, we're doing midpoints. Oh, I'm sorry. I thought we were doing midpoints. So, fourth square. 175 squared. 3. Oh, for right endpoints, 1/2 is f of 1/2 plus f of 1, f of 3/2 plus f of 2. Notice that this value is going to be larger because the first interval runs from 1/2 and the last interval runs out to f of 2. So I'm going to use larger numbers to find the area approximation. So bigger rectangles. It starts with a function value of f of 1/2 and ends at a function value of f of 2, as opposed to starting at 0 and ending at 3/2 for the first one. So 1/2 squared plus 3 was 3.25 or 13/4. One was 4. F of 3/2 was 21/4. F of 2, I know that to be 2 squared plus 4, which is 7. So 13/4 plus 4 plus 21/4 plus 7 is 19.5 as a decimal, or 39/2. So I'm going to need 1/2 of 39/2, which is 39/4. As a decimal, I bet that's about 9.75. Yep, looking good then. All right, what makes midpoints different? So what's in the middle of 0 and 1/2? 1/4. So this rectangle approximation would be 1/2 times f of 1/4. What's in the middle of 1/2 and 1? 3/4, so 0.75. Between 1 and 1.5, between 1 and 3/2 would be 1 1/4 or 5/4. Between 1.5 and 2 would be 1 3/4 or 7/4. Let's see, so we're going to have 1/4 squared plus 3, 49/16. 3/4 squared plus 3. 7/16. 5/4 squared plus 3. 73/16. Let's see, I need 7/4 next. 97/16. Working my way through this. Adding all those up, 49, 57, 73, and 97 is 276/16. Reducible down to 69/4. (69/8), or approximately 8.63. .625 or 8.63 if you round to the 100. We've got our 3 rectangular approximations intersecting on the left-handed side, right-handed side, and in the middle at the midpoint. Questions so far on these first few? Let's stack some trapezoids next then. This is going to be a different shape. So we're going to need to use a different summation to approximate our area. First trapezoid. Second trapezoid. Trapezoid. Fourth trapezoid. Trapezoid area is what? How do you find the area of a general trapezoid?
1/2 height times
Base 1, yeah.
Right. So if I think of a trapezoid that's standing up, like ours are, we have the bases running vertically on the left and the right with the height between them, separating the distance separating the two bases. All of these trapezoids have what for their height? 1/2. That's why I'm dividing my subintervals of equal length. So 1/2 times 1/2, half of their heights that are 1/2. Now, how are we going to do the bases? Remember our trick from yesterday? The first and last vertical line at x equals 0 and x equals 2. What's important about those? They're a base of only one trapezoid, right?
Yeah.
The right vertical line is the base of the first trapezoid only. And this vertical line is the base of the last trapezoid only. How about the ones in the middle? For example, at x equals 1/2, this is a base of how many different trapezoids? 2. So let's add up how many times each of these heights represents the base of a trapezoid. F of 0 plus 2 times f of 1/2 plus 2 times f of 1 plus 2 times f of 3/2 plus f of 2. multiplying some of these together. Half of a half is a fourth. F of 0 is 3. 2 times f of 1/2, that's 2 times 13/4, which is 13 halves. Plus 2 times 4, which is 8. Plus 2 times 21/4, which is 21 halves. Let's make that a better 13. Three plus 13 halves plus 8 and 21 halves is 28. Somehow got knocked here. Pardon. 1/2 was 13/4. I forgot the last one. F of 2 is the 7. $35. Quarter of 35. $8.75, or the 35/4 second. I forgot to do the f of 2 hanging on the very end here. I got so used to having 4 numbers down below, but I need 5 for this one. Because I have 1, 2, 3, 4, 5 bases, I need to have 1, 2, 3, 4, 5 different function values added together. I got so used to writing down 4 numbers, I forgot to bring down the f of 2, which was the 7 right here. 2 times f of 3 halves, which is 2 times 21/4, or 21 halves. I also need to add on f of 2, was 7. Great. All right. Were we able to land on these numbers here as our approximation? As I was walking through that myself, did I clear up any questions you guys had? Hunter, Justin, how we doing, guys?
I'm doing good. I made a lot.